Here I'm going to look at modulus inequalities. For any modulus equations or inequalities, we have to first remember what a modulus is. So the modulus of a value is its absolute or positive value. Okay, it has to be positive. So if 5, for example, the modulus of 5 is 5. The modulus of minus 4 is 4 because it's this positive value. If the modulus of x equals 7, then x could actually be 7 or x could be minus 7. So to go back to this, when we're dealing with modulus equations, as we don't know whether we're dealing with a positive or a negative value, we can't solve it unless we know for certain whether it's positive or negative. So what we want to do is we want to square both sides. So if it's a modulus equation, we square both sides, because then at least we know we've created a positive value. Remember, when we're dealing with inequalities, when you multiply or divide by a negative number, you have to change the sign of the inequality. But because we don't know here whether we're dealing with a positive or negative number, we have to square both sides, because at least then we know we're dealing with a positive number. So we simply square both sides to solve this. By the way, this is a past paper Leaving Cert question in 2016. We square both sides, we're left with x minus 4 to be squared is greater than or equal to 4, because that's what 2 squared is. There, and that goes to that when we square both sides. Then we expand the brackets. We square the first, multiply twice the first by the second, and add them together, and then square the second, and we're left with this. So we subtract 4 from both sides, and we're left with x squared minus 8x plus 12 is greater than or equal to 0. We then just factorize that using our standard methods. X minus 6, x minus 2 is greater than 0. So our critical values here are going to be 2 and 6. So there's a number of ways to see whether our solution set lies between 2 or 6 or outside of 2 and 6. We could draw the graph. Let's say that was 2 and that was 6. As we're looking for a set of values of x where our curve is greater than 0, we're effectively looking for this set of values here, this set of values here, because this is where my curve here is greater than 0, i.e. it's a positive side of the x-axis. So all the values of x where curve is greater than 0 are less than 2 and greater than 6. If you want to solve it the other way to find the solution set, we pick a value between our two critical values. So let's pick 4, for example, and we plug 4 into the equation. 4 squared minus 32 plus 12 is minus 4, which is not greater than 0. So therefore, that inequality is false, so our solution set lies outside the critical values, i.e. x is less than or equal to 2, or x is greater than or equal to 6. The reason why I'm saying greater than or equal to is because that's what we were given in our original inequality here. Okay, so just to recap, most important thing, when you're dealing with a modulus, square both sides. If you've got a modulus on either side, that's fine. Just make sure that you've got one modulus on either side of the equation, or else it becomes very messy.